Okay, this is where we stopped from the previous lesson, and let us continue from there. We stopped at seeing that the x-coordinate of the center of gravity is given by this, and then the y-coordinate for the center of gravity is given by that. So since the center of gravity acts at this and this, then we can give this as, you see, we always need, we get this, you see this one is the same, so meaning we are going to be dividing always by the weights of those particles. Then you see that we always multiply with the x-coordinate and then the y-coordinate. So in simple terms, we get the weight, then times the y-coordinates as you see there. So we get this times the corresponding coordinates. We get the second weight times the corresponding coordinate plus up when we reach the last weight over the sum of the weights, as simple as that. The same thing here is what we are doing there. Basically, that's all we need. So if the equations are given in position vectors, they give us them like this, I notations. The same idea works there. Okay, let us go through some examples here. Particles of weights, 12. So we read as we summarize. So we have weights, 12. I'm going to read. We have the weights. So this we're going to call it weight 1 is 12 newtons. Okay. 8 newtons. So this one is going to be our weight 2 as 8 newtons. And our weight 3 as 4 newtons. Act at points. So this one is going to be our x1. The first point, we give it 1, -3. So this is the x2, the corresponding coordinate for this weight is 0, 2. Then x3, which is going to be given by 1, 0. Respectively, find the center of gravity of the particles. We know that always our center of gravity, these are the coordinates, and so that it's going to be given by the weight. Okay, let me modify it so that we write it in okay. I'm going to say this is going to be the sum of, we get the weight of the particles, then we get the x coordinate, then also the y coordinate over the sum of these weights. As simple as so. The whole of this formula can be summarized like that. From I, okay, let me put there, of course, with our I equaling to from 1 to up to n. As simple as that. So, now if I'm to organize it, I'm going to be having x bar, y bar equaling to. Now, when I is 1, we are going to be having this w1, x1, y1. When I is 1, then plus. When we are summing, when I is 2, we have w2 into x2. This is always the same, y2. Then plus. Our coordinates, the last to start there, 3 weights. So w3 into x3, y3. Then we cross the whole over our weights, w1, w2, w3. So these ones, let me just say this is x1, y2, this is the coordinate there, y1, and also this is y3. Those are the coordinates we have. Substituting them there, so this is going to be the weight. There we are going to be having the first weight is going to be 12 into 1 -3 plus 8 into 0, 2, then plus our 4, this weight which is 4. We have our 4 into 1, 0. The whole divided by, you add these weights. 12 plus 8 plus 4. And you see, when you sum, this is going to be 12 plus 0 plus 4. When you open this, you get 12. 0 plus 4. 12 plus 4, we get 16. Then this is negative 36 plus 16, that's negative 20 plus 0. So negative 20, the whole, when you sum, this is 24. And then you get this, and we divide with this. So this is going to be now 16 over 24, then negative 20 over 24, which will give us by 8, 2, by 8, 3, by 4, negative 5, by 4, 6, and so, therefore, this is our x bar, y bar equal to that. So that our x bar now, the coordinate is going to be 2 over 3, then our y coordinate is going to be negative 5, all over 6. And so that will be the center of gravity. Center of gravity is different. If they ask you for the center of mass, then you just use masses, as simple as that. So the center of mass, as here, center of mass. Center of gravity, we are dealing with weights. Okay, find the question vector of the center of gravity. Even here they want the center of gravity, which lies on x-axis at points when they are giving us these masses respectively. So now they are giving us masses. How do you convert masses to weights? You know that already our weight is equal to mass times g. So meaning our weight 1 is going to be the first mass, which is 1 g. This is the coordinate there. They are giving us the first coordinate is going to be 0, 2. Then our weight 2 is going to be the mass times g. Then the coordinate where it's located is there. Then our weight, third weight, is going to be 2 times g. It's located at 0, 5. So getting our x bar, y bar, is going to be the first weight 1 g times all to the coordinate plus the second weight 5g 0, 4 plus the third weight round over. Then I sum these weights. It is going to be 1g 5g plus 2g. And that's what we get. This is 0, 0. So up here, 1 there adding 0. 0 then down, this is 1g, it's going to be 20, so that's 21, that's going to be 31, this is 10, this is 10, 20, that's 30 times 2, so that's going to be 32 g, so they're all over. When I sum these ones, I get 8 g. Then when we divide, this would be now 0 over 8g, then 32g over 8g. And so now my x bar, y bar is going to be, when you divide there, you get 0, and you see there, you get 4. So therefore, our center of gravity is going to be x bar, y bar is going to be 0, 4. It is. So basically, that's how we handle it. You give it as a coordinate always, just that space was in there. So that's how you just substitute into this formula. When you know this formula, rates are going to be very, very okay. You get the weight times the coordinate corresponding weight, corresponding coordinate weight, corresponding coordinate over the sum of those weights you have. Not when they ask you the center of gravity, and then when they ask you for the center of mass. Center of mass, you use the masses. Center of gravity, you use weights. I wish you well.